Okay, so hopefully you've read through this problem, but a forester is 40 feet away from a tree. Here they are. And so here's the tree, and we're going to assume the tree makes a right angle with the ground. They want to know how tall the tree is. That's something we don't know. So you can imagine a right triangle, because it says the forester is using an inclinometer to measure the angle to the top of the tree. So that means the forester standing right here uses a device to look at the top of the tree, and it says that it's 70 degrees from where he's standing to the top of the tree. So whenever you have a right triangle, and especially when you're dealing with some sort of angle, you can use trigonometry to help you find some things about that triangle. So trigonometry works, the three basic trig functions are sine, cosine, and tangent. And depending on what you have available in that triangle is what you're going to choose for which of those three trig functions. Sine is always the opposite and the hypotenuse. So you take the opposite side divided by the hypotenuse side. That's a sine ratio. Cosine is always the adjacent divided by the hypotenuse. And tangent is always the opposite side divided by the adjacent. And I'll show you what an opposite, adjacent, and hypotenuse are in just a second. But here's that mnemonic device you might have heard in class, SOHCAHTOA, a bunch of times. That's just a quick way of remembering sine, cosine, tangent's definition. Okay, so when we're choosing which one, we need to see what we have available in our triangle. We've got this 70-degree angle. Angles are none of these, okay? These are always side lengths, O and A. So we have an angle, and we want to, we don't have it, but we want to use what's opposite of 70 degrees. We want to have O in our formula because we need to solve for x, the opposite side length. We don't have the hypotenuse. The hypotenuse is always the side across from the right angle. So forget about sine, forget about cosine. Those involve the hypotenuse. Tangent's our guy, or girl, I guess. Tangent is what we're going to use. And we'll plug in the opposite and adjacent into the tangent formula in just a second. But whenever you make your trig function, always put your degree inside parentheses. This is called the argument of the tangent function. And you always set the trig function equal to your trig ratio. The opposite divided by the adjacent goes left to right in that order. So the opposite of our angle is x, and the adjacent of the angle is the one that's not the hypotenuse and not the opposite. So the adjacent is 40. And that's it. Now we just have an equation to solve. Okay. So if that was confusing, you'll get to see this in another problem in just a second. There's not too much more to solve here. So make sure your calculator is in degrees. I typed in 70 in my Windows calculator, and I'm doing tangents. That's 2.7475 roughly. 2.7475 equals x over 40. So here's some algebra. To get x by itself, we want to do the opposite of divide 40 to both sides. So we're going to multiply 40 to both sides. So we got 40 times this stuff. So that's 109.9. Okay. So that tree is about 110 feet. So if the house is 120 feet away, that's pretty close. It's a little risky. This angle measurement's going to be a little bit off, which is going to throw off this too. So that's close enough where you might want to cut it. I guess the top of the tree isn't very heavy though, so if it hits the house, it's not going to do much damage. Okay, so that's a basic use of a trig function. We're going to do the same type of thing with this ladder example. We got a house. Here's my house. There's a ladder that's leaning against the house, so here's my ladder. And it's saying the ladder is placed at a 75-degree angle with the ground, so this is 75 right here. That's the 1 in 4 rule. If you go for every 4 feet vertically, you want to go 1 foot horizontally. So 8 and 2, 12 and 16. You could solve this problem with the 1 in 4 rule, but we're doing trig, so in case there's a situation where you got a ladder and you can't use the 8 and 4 rule, the 4 and 1 rule. Contractor needs the ladder to reach 4 feet high in the house. Will a 20-foot ladder work? Well, let's solve for what we can have for the length of this ladder. That's what we need to solve for. And then we know they want to reach 20 feet up on this house, so this side length is 20. And so when deciding SOHCAHTOA which trig function we use, we have the opposite, and we want to solve for the hypotenuse, the one across from our right angle. So if you write out SOHCAHTOA, here it is. It's sine, because that's opposite and hypotenuse. So we say sine of our angle that we're talking about is equal to the opposite divided by the hypotenuse. So just like before, I'm going to type in 75 in my Windows calculator, hit sine. Ugh, gross. This is 20 over x. You can't solve for x if it's in the bottom of a fraction. So multiply both sides of this equation by x. And that 0.9659 is multiplying to x. So you want to do the opposite. You want to divide both sides by 0.9659. So it means x is going to be 20 divided by 0.9659. So that's 20.7. Okay, so the ladder they need is a 20.7 foot ladder. Yeah, this ladder is going to work. A 20-foot ladder is going to be fine. Okay. Wait a second. No, it's a little bit short. Sorry. According to these rules, you need a 20.7 foot ladder, so you're going to have to stretch a little bit because there's an extra 0.7 you're not going to reach with a 20-foot ladder.